Good morning. Today we are going to cover the unit circle. Today's lesson title is 8.2, the unit circle. Today's date is Wednesday, May the 5th. We're going to start with what is the definition of the unit circle, and we're going to watch a video clip that will help you to gain some insight on the unit circle and how it's used. The unit circle is a circle with a radius of 1 unit. The center of the circle is located at the origin of the coordinate plane. Let's watch this video, and then we're going to continue with some more notes.
Hi everybody, this is Mr. Bourne from Minnesota and his trusty cat. And this tutorial will be on the unit circle, radians, angles, and points. Now if you want to learn this fast, this is the tutorial to watch. What you will learn: what the unit circle is, how degrees and radians relate, finding radian measure, and finding the XY exact coordinates of important radian measures, all under 8 minutes. First, let's talk about what a unit circle is. What you're seeing is an XY coordinate grid. This is a plane with pairs of coordinates. And a unit circle is centered at the origin. There it is, little unit circle with a radius of 1. Let's zoom in to get a little bit of a closer look at it here. Okay, there we go. Now, radius of 1 means that I can lift out this little blue piece here, and this is the radius. And as you can see, no matter where I hold it, it's got a radius of 1 exactly. Now, if we take that radius and we curve it, here's a curved piece. It's the same thing, it's curved, and I've colored it purple. If we take this curved piece and we get a few more, 1, 2, 3 more of them, these will fit exactly in the circumference of the circle. But in just a second you'll see, hang on. That there is just a tiny little piece left over. So the radius will fit around the top hemisphere of the circle 3 times plus a little bit extra. And this little bit extra, which is right here, is 0.14 long. So it takes 3.14 radiuses or radians to fit around the top half of the circle. Okay, so let's move that little 0.14 piece in there. Okay, 3.14, that is pi. So around the very top half of the circle is pi radians, and the bottom half of the circle is another pi radians. So the complete circumference around a unit circle is 2 pi radians. This should be familiar. If we go to the formula for the circumference of a circle, it's circumference equals 2 pi r. Well, since we've got a radius of 1, that makes the math simple, right? There you go. So now you know how the formula got to be that way. Okay, now I'm going to tell you how radians and degrees relate. So what you're seeing here is a slightly different picture of the unit circle, and the red side, which is moving around, is going to be called the terminal side, and the green side is going to be called the initial side. So I put it in your heads that a radian is a length, and I'm going to adjust this so that, there we go, the terminal side is 1 radian away from the initial side. So this is a length along the outer edge of the circle here. But a radian can also be describing the angle formed by the terminal side and the initial side right inside here. Okay, well, let's bring degrees into this. So there we go. We see this is 57 degrees, and that is the same thing as 1 radian. All right, well, it might not seem very natural and they don't quite go together, but let's just move this around here and we'll see where the logical matchups are. Right here, at exactly halfway point on the way to 1 complete pi radian, this is pi over 2 radians, and that's 90 degrees. And over here we've got 1/4 pi, or just pi over 4. This is the same as 45 degrees. And over here we've got 3/4 pi is 135 degrees. And of course here is 1 complete pi, and that's 180 degrees. But there's a few other important ones. There is 30 degrees, which is 1/6 pi. 60 degrees, which is 1/3 pi. 120 degrees, and although the radians didn't make it look nice, this is actually 2/3 pi, or 4/6 pi. And over here, 150 degrees, which is 5/6 pi. Okay, let's move on. Let's talk about how to convert degrees into radians. The formula for converting degrees to radians is degrees divided by 180 times pi. So I'm going to move this randomly here and just kind of put it there. And we see we've got 72.06 degrees. All right, let's bring in a calculator and try to convert that. 72.06 divided by 180 and multiply that by pi. 1.2576, and that is the angle in radians. Okay, so let's convert between given radians to get a degree measure. Here's the formula for doing that. You take your radians, divide it by pi, and then multiply by 180. Here is the calculation for that. I encourage you to give this a try on your calculator. Just put in 3/4 times pi divided by pi times 180, and there we go, 135 degrees. Okay, we're on to the last part. This is the complete unit circle, and I'm going to show you how you can find the various points of interest, the x, y coordinates of places along the edge of the unit circle. What you're looking at is the upper right quarter of the unit circle. Take a look here at the coordinates for 30 degrees or pi over 6. The x coordinate is square root 3 over 2, and the y coordinate is 1/2. So think of this as being part of a triangle, with the vertical leg on the bottom being square root 3 over 2 long on the x-axis, and being 1/2 high on the y-axis. And naturally, the hypotenuse is 1 unit long. Now here's where sine and cosine come into play. If you take the sine of pi over 6, you will get 1/2. And if you take the cosine of pi over 6, you will get square root 3 over 2. Now, when you do this in your calculator, you'll get a long decimal. But you can confirm that this is square root 3 over 2 by typing it in and taking a look. A final word on some strategies for helping you to memorize some of these XY coordinates along the outer edge. Look for symmetry. Look and see how similar and different the 30 degree and 60 degree mark are. Notice that all the starting x coordinates for everything on the left side of the y-axis is negative. And keep in mind, the only numbers that you have to memorize are 1/2, square root of 3 over 2, square root of 2 over 2. All right, well, hey, thanks for watching this video. Hit the like button if this was helpful, and share it with your friends and your teacher. All right, bye.
Okay, so that was just a quick intro, pretty thorough though, but let's delve into a little bit more about the unit circle, okay? So as you saw that the coordinates are written as x comma y as you go around the unit circle. So when you are being asked for the exact cosine value, you are looking at the x coordinate of the ordered pair. When you are being asked for the exact sine value, you are looking at the y coordinate of the ordered pair. When you are being asked for the exact tangent, you are doing y divided by x. Okay? So let's practice some of this. Before, though, a mnemonic device that will help you to remember which quadrants the functions are positive in is the mnemonic device All Students Take Calculus. So in quadrant 1, all of the trig functions are positive. This is quadrant 1. In quadrant 2, sine and its reciprocal function are positive, sine and cosecant. In quadrant 3, tangent and its reciprocal function, cotangent, are positive. And in quadrant 4, cosine and its reciprocal secant are positive. Okay, so in quadrant 2, cosine and tangent are negative. In quadrant 3, cosine and sine are negative. In quadrant 4, sine and tangent are negative. Okay, let's do a few of these. In which quadrant does theta lie? So theta is our unknown measure or our measure of the angle. If the following statements are true: cosine of theta is less than 0 and sine of theta is less than 0. So my suggestion is we create a quick coordinate plane. Okay. Oops. Okay, so we create a coordinate plane. If I know cosine is less than 0, it cannot be quadrant 1 because everything's positive there. And it cannot be in quadrant 4 because cosine's positive there. And if I know that sine is negative, sine is less than 0, it can't be here. So it's got to be in quadrant 3. Quadrant 3 is our answer. Okay, next one. In which quadrant does theta lie if sine is greater than 0, but tangent is less than 0? Okay, so I know I can eliminate quadrant 1 because everything's positive there. Tangent's less than 0, so it can't be quadrant 3 because tangent's greater than 0 there. And from the remaining 2 potential quadrants, if sine is greater than 0, it has to be in quadrant 2. Okay, we're going to move to some exact values. Find the exact value of tangent pi over 6. So tangent pi over 6, for some people, it's helpful to think of it as a degree measure. Pi over 6 is equivalent to 30 degrees. Okay, 30 degrees is on the unit circle in quadrant 1. The ordered pair at 30 degrees is root 3 over 2, 1/2. In order to get the exact tangent value, I'm going to do y divided by the x. Okay, 1/2 divided by root 3 over 2, which we know when we divide fractions, we have to multiply by the reciprocal. Oops. Okay, our 2's will cancel. We have 1 over root 3, and then we rationalize, so we multiply by root 3, top and bottom. And we get, for the exact value of tangent pi over 6, we get root 3 over 3. Sine 300 degrees. 300 degrees is in quadrant 4, okay? Quadrant 4. So what I do in my head is I think of the quadrants, okay? Quadrant 4, 300 degrees is closest to the y-axis. I remember in my mind that the ordered pair closest to the y-axis is the ordered pair 1/2 negative root 3 over 2. Okay? 1/2 negative root 3 over 2. They're asking for the exact sine value. Sine, you look at the y coordinate in the ordered pair. So the exact value would be negative root 3 over 2. Okay, tangent 240 degrees. 240 lies in quadrant 3. Quadrant 3. So we know tangent's positive in quadrant 3. So I take in my mind and I make a quick coordinate plane. 240 is here. Both of the ordered pairs are negative because we know tangent's positive and it's y over x. Closest to the y-axis is the ordered pair negative 1/2 negative root 3 over 2. To get the exact tangent value, we do y divided by x. So negative root 3 over 2 divided by, that looks like a plus sign, divided by negative 1/2. So of course the negatives will cancel. So let's just write it root 3 over 2 times 2 over 1. When we flip, multiply by the reciprocal. 2 over 1. The 2's cancel, and we are left with the exact value as root 3 over 1, or just root 3. Okay? Sine pi over 4. Pi over 4 is equivalent to 45 degrees. 45 degrees, right? 45 degrees is in the first quadrant. It's the middle ordered pair value, root 2 over 2, root 2 over 2. Because I'm looking for the exact sine, I know that's the y value, and so my exact value is root 2 over 2. Cosine 990 degrees. Clearly, 990 does not fall on the unit circle, right? So we have to find a coterminal measure. We talked about coterminals on day 1. So to find coterminals, you add or subtract 360 degrees or multiples of. Well, if I need to get on the unit circle, which is between 0 and 360 inclusive, then I need to subtract 360 2 times. So 360 times 2 is, or you know what, let's just do it like this. Subtract 360, you're at 630. That's still not on the unit circle. Subtract 360, you're at 270. 270 is on the unit circle at 270 degrees. That's exactly one of the quadrantal angles, which is here. Oops. The ordered pair at 270 here is 0, -1. Because they're asking for the exact cosine value, our answer is 0. Okay. This is a little bit of what's called inverse trig. So this says find all of the angles on the unit circle from 0 to 360 that solve the following equation. Cosine of theta is negative root 3 over 2. So we need to find where on the unit circle is your x value negative root 3 over 2. Well, I know root 3 over 2 as an x value will fall closest to the x-axis, that ordered pair. If cosine's negative, my only options for the quadrants would be in quadrant 2 and in quadrant 2 and in quadrant 3 because cosine's negative there. So the x value for negative root 3 over 2 closest to the x-axis would be the angle here and the angle here. Okay, they want it in degrees. So in degrees, that would be 150 degrees or 5 pi over 6 radians. Okay, and in quadrant 3, that would be 210 degrees or 7 pi over 6. Okay, so you're going to have your theta equaling 150 or 210 degrees. Okay, real quick, I want to show you on Desmos why that works, how that looks. Okay, so if I did in Desmos, oops. Okay, I'm going to go to functions and I'm going to go to cosine. We said 150. Okay, and I'm going to do cosine 210. Okay, look how they're the same. See, they're the same decimal. And now watch this. Negative root 3 over 2, same exact decimal. Okay, so at 150 and 210 degrees, the exact value would be negative root 3 over 2. So basically, you're going backwards. Okay, let's do another one. This time we want to find when is cosine negative 1/2. Okay, well now, again, because we're finding cosine, we need the x value to be negative 1/2 in our ordered pairs. So we established in the last problem, for cosine to be negative, it's got to be in quadrant. Sorry, my computer is messing up. Okay. It's got to be in quadrant 2 or quadrant 3 because cosine's negative. Now, because we're looking for the x value to be negative 1/2, the ordered pairs that are closest to the y-axis this time are going to be where your x value is negative 1/2. So we're looking at the ordered pair here and the ordered pair here, closest to the y. So in quadrant 2, the ordered pair right directly after 90 degrees, which would be 120 degrees. Okay, 120 degrees. So when theta is 120 degrees, okay, when theta is 120, the exact value for cosine 120, we're going to get negative 1/2 because the ordered pair here is negative 1/2 root 3 over 2. Now in quadrant 3, closest to the y-axis, again, is the ordered pair negative 1/2 negative root 3 over 2. We're only concerned with the x value. And so that would be 240 degrees there. Okay. And again, it's asking for the degree measure, but as a radian measure, that would be 2 pi over 3 or 4 pi over 3. Okay, and those are just radian equivalents. All right, real quick, let me show you in Desmos. Okay, so this time we said 120. Okay, look at how it says negative 1/2. And we said 240, negative 1/2. Okay, and so our equivalent thetas 120 and 240. Okay, let's do a couple more. Sine of theta is positive root 2 over 2. So one thing we immediately recognize is sine of theta is positive, okay? And so that can only happen in quadrant 1 and in quadrant 2. The root 2 over 2 ordered pairs are the ones directly in the middle, here and here, which would be our 45-degree angle and our 135-degree angle. That is where sine is positive root 2 over 2. Watch on Desmos real quick. We're going to change and we're going to go functions. We're going to hit functions. We're going to hit sine. And I'm going to put 45 degrees. And I'm going to do sine of our other one, which was 135 degrees. See how they're exactly the same. And now watch, we do root 2 over 2, and it's the exact same decimal. Okay? You are responsible for, in Delta Math, completing the assignment titled 8.2, the unit circle.